All right, guys. This is one of the most important part that I need to actually talk about. So we are going to check our introduction on the compressors, right? Or air compressors, but we are going to focus with no clearance when the clearance is not involved. Yes, there are some things that are to be considered, which will affect us in the application or in calculations of our compressors when the clearance is involved. But we just want to focus when it is not involved, and you see majorly on the calculation of the power, the work done, talking of the efficiencies is the most important. So this is the major class that you need to actually understand how to apply in our calculations. All right, so we're not going to waste much time. We are given, when the clearance is not given, you shall have a typical diagram of this nature for our compressor. Where, remember, this is an air compressor where the air is entering at the inlet values. We are saying at a point 1, which are our inlet. The inlet at a point 1. I'm just going to call this 1. So at that point 1, we have the volume corresponding, the pressure corresponding, the same thing at our point 2. We have got the volume there corresponding and the pressure corresponding. This is the PV diagram, pressure versus volume. So what is happening here, take note, we are saying the clearance is not involved. There is no clearance volume. All right. We shall see the major effect when the clearance is there. So what happens is that on a single stage reciprocating compressor, this volume that we are referring to as V1, the whole of it up to this point, that is the cylinder volume, the swept volume, our stroke volume. When there is no clearance, V1 is equal to Vs. And since it is the cylinder volume, remember a cylinder, we have got a diameter and we have the stroke length on a cylinder. So thus it is equivalent to the area times the length, pi d squared over 4 times the stroke length. That is our V1, Vs, the swept volume, if the clearance is not there. And this one, take note on this, I want you to be careful, guys. The swept volume, or our V1, is measured in cubic meters. Take note on the units. It is taken in cubic meters. There is another volume that they will give us, and that volume, it enters also at the inlet just like V1. But that one, it is entering per unit time. It enters per unit time. Per unit time. Volume per unit time. That one, it's a very, very important special type of volume. I have to talk about this so that we understand where we are going. It's not about answering the questions. We need to know where we are going. So that volume is referred to as the effective volume, VE, effective volume. Effective volume. So this is the volume per unit time. What am I trying to say? Whenever they give you a volume, cubic meters per second, cubic meters per minute, cubic meters per hour, per unit time, that one, it is the effective volume. It is measured in cubic meters per unit time. So I'm not going to specifically mention to say it must be like this unless we are using for power. I'm going to talk about that specifically. It must be cubic meters per this unit of time. So the unit time on the compressors, it is something that was taken from the speed. It is the speed that also carries the unit time. Remember our speed, it is revolutions per unit time again. Revs per second, revs per minute. So what does it mean? It means these two, they work hand in hand. The reason for us to have VE in cubic meters per unit time, it is because there is the speed in revolutions per unit time. So what does it mean? It means that we can find this effective volume from the swept volume, our V1. If there's no clearance, remember I said swept volume is V1. So finding, or let us just say the relationship, so that we don't have a confusion. This is the relationship. The relationship between V1, which is the swept volume, and the effective volume. We want to see the relationship that is between these. Remember, we said the swept volume, it is just cubic meters. Sometimes they might say, calculate the swept volume in cubic meters per cycle. Whenever you are given these units, whenever you're given this thing here per unit cycle, per cycle, it does not affect anything. If you are given your answer, maybe our answer is 5 kilograms. If I want, I can write it as 5 kilograms per cycle. There's nothing there. If my answer is maybe 5 cubic meters, I can write it as 5 cubic meters per cycle. So per cycle simply means write your answer in the units that you are supposed to have it. So if you are supposed to have your VS in cubic centimeters, it's just those cubic meters. So you just write per cycle, there's no effect. But per unit time, per unit second, per minute, that one, it is an effective volume. The time is involved. So this is the relationship. The relationship says that for us to have VE, we are going to multiply VS times the speed to have what? To have VE. Okay. So what am I trying to say there? VE is equal to VS times N. It follows that if you want this VE to be in cubic meters per minute, it means this speed must be in revolutions per minute. If you want this volume to be in cubic meters per second, this speed must be in revs per second. This must be together per second. But remember, per unit time, per unit time. What time is it given here? Second, second. Minute, minute. It must follow suit that. If it is not follow suit that, it means that is wrong. So like I said before, if that is cubic meters per minute, so the relationship is this one. All right, that is the relationship. So I'm not going to talk about to say this must be the unit unless you are calculating power. Always, it must be cubic meters per second. So if this is cubic meters per second, it means this must be revs per second. So these units, they are per unit time, which is the same. All right, that is it. So this is your swept volume, your V1. Your V1 is direct cubic meters. That one is cubic meters direct. Cubic meters. So there are things like maybe it is a single acting, double acting. Whenever it is a double acting, that's where you see this being multiplied by 2. VE is equal to VS times 2N. Whenever you are given a double acting, the speed is multiplied by 2. The speed is multiplied by 2. So it means I can make, I can make VS the subject, which is the swept volume from this. All right. So like I said, if this units here is cubic meters per second, guys, take note, this must be revs per second. If this is cubic meters per minute that you want on your answer, it means your speed must be in revs per minute. They must carry per minute per minute. Be careful there. Okay, so that means I can even make VS the subject in this manner. It follows that, so this one, the 2, it's on a condition when it is what? Double acting. So it means I can even make VS the subject if I want. VS is just gonna be VE over N. So that is it. You have VS, the swept volume. The swept volume is always in cubic meters, not cubic meters per this time, no, cubic meters. So it means the N is there to neutralize our units back to cubic meters. So provided that this is in cubic meters per second, this must be in rest. That part does not change. If this is in cubic meters per minute, it means your speed must be in revolutions per minute so that your volume will be in cubic meters. That's the idea. That's the idea there. So this is the relationship that we have between what? Between VS and VE. Meaning to say, when it is a double acting, we are going to have our VS being multiplied by 2. So the 2 there, it's when it is a double acting. Double acting. You see that your answer is going to have a 2. Just like this, you divide this, so it will be over 2n, divide by 2n. So that's it. But for a single acting, you just use your n as it is. For a single acting, double, you multiply by 2. Okay, so this is the first part that I want you to understand about these two. So we are saying the volume entering, there is V1, which is the swept volume, but there is also the effective volume. These two, they are different. Okay, so someone is asking, why are we talking about, why are you spending your time on this? What is the importance of this? Okay, you will see. This is the importance. With these guys, I want you to understand this. Remember, we are working with no clearance. The clearance is not there. So we are going to calculate 2 major things there. One, it is the work done per cycle. The work done per cycle. Whenever you are given to calculate the work done per cycle, they are simply saying calculate the normal work done that you are used. Remember, I said per cycle. It means that thing as it is, the work done as it is. So they are simply saying your answer is supposed to be in kilojoules, but you can even write kilojoules per cycle, does not affect. So the work done per cycle, it was supposed to be given like, guys, be very careful. I want you to be with me. The work done is going to be given by the formula P1 V1 into N over N1. All right, I'm going to explain this. Just be with me. P2 over P1 to the exponent of N minus 1. Remember, this interchanges minus 1 like this, which is in kilojoules. So what matters there is this. This is the one that matters here. This here representing our V1. But remember, we are dealing on a condition where there is no clearance. The clearance is not involved. And I said this V1 is the swept volume. This is our stroke volume, the swept volume. Which is what? In cubic meters or cubic meters per cycle, if you want to write it that way. So it gives you direct the work done. But remember, guys, from our gases, if you're dealing with the gases, remember this is air compressor and air. We are dealing with what? With gases there. P1 V1 is equal to MRT1. We saw that when we were dealing with gases, isn't it? We saw that this is equal. So if we are saying P1 V1, we can also manipulate the same formula and write it in terms of what we understand in terms of the gases, because we are dealing with air. Since we understand that P1 V1 is equal to MRT1. it means if we are given mass, we can use that same formula there. If we are given the mass, we can conclude that this also can be written as mRT1 into n over n minus 1 into P2, that is over P1, to the exponent of n minus 1 over n, like this, in kilojoules, provided that this mass that we are seeing is in kilograms. You are obtaining what? The work done per cycle. Per cycle, which is just the normal work done. The normal work done. Remembering that there is no clearance, V1 is equal to Vs. We talked about that. Okay, now let's go to VE. With the same formula, there is only one thing that is going to change there in order for us to calculate what is now called the power. The power. The power is now work done per second, per unit time second, not per minute. No, not per minute. Not like that. Per second. Why per second? Let's go to our N2, engineering science N2. Power is equal to work done over time. We talked about that. The time was measured in what? In seconds. Seconds. So the moment you have work done over second, per second, guys, everything changes. It's now power. So we are simply saying it's no longer kilojoules per cycle. No, it's no longer per cycle. It's now kilojoules per what? Per second. Because remember, it's per unit time in seconds. So it's kilojoules per second. And the kilojoules per second means what? Kilowatt. Kilojoules per second is equivalent to kilowatt. Remember, joules per second, it was 1 joule per second, it's 1 watt. So if it is kilojoules, kilowatt, that is the idea. Work done. Work over time. Time in what? In seconds. Now let's conclude. What is it that carries per second? Because this was kilojoules here. This was kilojoules. So it's either you are going to take this work done here, where it is here, where it is. You convert it to power. You calculate work done first, then power will be equal to work done. In order now, guys, take note there. In order for you to have per second, it means you are having this work done per cycle times the speed. Take note, you multiply it to the speed n. Let me just write n so that we don't have confusion. But this speed, because we need per second then. We need per second. So the speed must be in revolutions per second, not per minute. No, per second. So that your power will be kilojoules per second, which is in kilowatts. For a double acting, it is going to be multiplied by 2. So the 2 there is when it is for a double acting. Okay, so it's either you are going to calculate this. Remember, the work done per cycle is this one that we calculated before, this one. So it's either you calculate work done per cycle, then you use the speed at the end to calculate your power. You use your speed at the end. Okay, guys, let's do this. Let's do this. Why are we complicating this at the end? It's not a matter of fact. If I know this, if I'm someone who is understanding this, I have to use this. It's not a matter of fact. This one. I understand this, I can use this. Meaning to say, if I am given power and I want to calculate work done per cycle, I simply divide by n. But for a double acting, I divide by 2n. So it means work done per cycle is equal to power over N. You just divide by N. But for a double acting, work done per cycle is equal to what? Power over 2N, whereby this N is in revs per second. Must be revs per second. So that's the relationship. Okay, but guys, let's go back because we want something that just has per what? Per second. This is what we want. We just want something that carries this per second. So let's go back and see what made us not to have per second here. It was because one, if you're using your mass, the mass was just kilograms, okay? If you were using V1, which is your swept volume, if there is no clearance, which is your VS, the VS is just cubic centimeters. There is no time per unit second. There is nothing like that. So that's why your answers were just kilojoules per cycle, not per second. So what will give us, because we just need kilojoules per second, and if there is kilojoules per second, there is what? There is a kilowatt. And what is it that carries that? Let us go back here. It is the effective volume here. Remember what I said about the effective volume here. It is measured per unit time. Guys, it is measured per unit time. So what does it mean? We can conclude that instead of having to calculate work done first, where we want to calculate power, instead of us having to calculate that work done, no, let us not do that. Let us use the formula straightforward. It follows that, therefore, power is equal to P1 times VE. The moment you use V, guys, be careful there. The moment you use this VE, because VE is in cubic meters per second, automatically your power, your energy, your work done is kilojoules per second. It's no longer work done. It's work done per second, which is now power, kilowatt. So that's the tricky part. You just need something that carries per second. That's the tricky part. You're done. You're done with this. So the rest of the formula is remaining as it is. N over this as it is. So you're just gonna have the remaining of the formula. So remember, this was into N over N minus 1 into P2 over P1 to the exponent of N minus 1 over N minus 1. This is now power. Why? Because we are obtaining, because of this one. This one is the one that caused it. If this was not there, it was going to be work done. But the moment that there's a per second, it's no longer work done. It's now work done per second. Kilojoules per second, which means what? Which means kilowatt. That's it. You're done. So you can use that formula straightforward. And remember the relationship now. The relationship to find VE when given VS. How do I find VE? I go back here. VE is equal to VS times N. Or VE is equal to VS times 2N for a double acting. So meaning to say I can calculate VE if I am given what? VS, the swept volume. Sometimes they do give you the swept volume, the effective volume straightforward. As long it is volume per unit time, that one, it is the effective volume. It is the effective volume. So you use it as it is, but only you have to convert it now when it is not per second. You have to divide to the units so that it is given as cubic meters per second, so that you obtain what? Kilojoules per second, per second, per second. All right? Per second, per second. Kilojoules per second means what? Means kilowatt. I talked about that. So that's why you have to change this to cubic meters per second. So it depends. Maybe you are given cubic meters per minute. What are you going to do? You have to divide this over 60. That will be cubic meters per second. Maybe you are given cubic meters per what? Cubic meters per hour. You have to change that cubic meters over 3,600. Remember, 1 hour is 3,600 what? seconds, that will be cubic meters per second. So you divide by what is there to convert how you are given. Are you given per hour? Are you given per minute? So you have to convert to per second, VE, effective volume per second. That's it. Guys, with this information, you will never have a challenge whenever you're given a question on compressors. You need the formula. So the formula, this one that I'm talking about, on your formula sheet, it is given as W. What do they mean? They mean it is the work done per second. So it's power. It's no longer work done. It's now power. If you want to calculate work done, you want to use the formula for work done, you use this one, but this must be V1. Cubic meters, not cubic meters per second. Once it's cubic meters per second, you are now calculating work done per second, which is what? Which is power. So be careful there. Be very, very careful. So we are going to talk about more the application of the efficiencies and so forth. So before we talk about that, I just want us to check one or two examples. Then we shall see how do we apply these formulas before we take a consideration. Let us just check one or two questions. All right, there I'm given a question, which is an example, actually example 1. A single acting, remember we talked about this, the single acting, then a single cylinder, all right, it can be single, you can have the number of cylinders. So that one mostly in our N6, we shall see how the number of cylinders are affecting. But this one is a single acting, meaning to say the speed is not affected. Remember, the speed is the one that is affected by being what? By being single acting or double acting. When it is single acting, you just take your speed as it is. So speed, you just take it as it is. It's affected by 1, so it's not that affected. But if it is a double acting, your speed always, you multiply it what? By 2 when it is a double acting. So there it's a single, so your speed as it is. So this, it has a cylinder diameter of, so we have got a cylinder diameter in meters. If you divide by 1000, this is 152,4, so it will be 0,1524 in meters. The stroke length 228,6, that's a 0,6 there. So if you divide by 1000, the stroke length will be 0,2286 in meters. That's our stroke length. So the question is, air is drawn into the cylinder at a pressure of, it is entering at P1, 103,4 kilopascal, and a temperature of 17 T1, 17 plus 273, that will be what? If you add, this will be 290. So that will be 290 Kelvin. Is compressed adiabatically. So an adiabatic compression, those are theoretical calculations. For practical calculations, we deal with a polytropic, where we use N, a polytropic. So an adiabatic, where we use gamma. These are theoretical calculations, but you just use the same formulas, but they are referred to as theoretical calculations, okay? So this is it there. P2 is given as 620,4 kilopascal. Then calculate, check here, theoretical. These are just theoretical values, all right? So they want you to calculate the theoretical power in kilowatts. So we need to calculate what? Power in kilowatts. And I said the kilowatts means what? Kilojoules per second. That is what they want. Required to drive the compressor at this speed. So the compressor is moving at a speed at 100 to move at a speed of 100 revolutions per minute, given that for air, R is equal to what? R for air is 0,286 kilojoules per kilogram Kelvin, and gamma is given as what? As 1,4. Like I said, adiabatically, it's for theoretical, but as we are supposed to work with a polytropic where we use N. But the formulas are just the same. All right, the formulas are just the same. All right, this is our information, guys. The question there was to calculate the power. So we are not told anything that is to do with the clearance. Whenever there's a clearance, they will give you a percentage that VC, the clearance is equal to this percentage or a decimal. Maybe VC is 5% of the swept volume. When you are not given any statement that connects the swept volume and the clearance volume, it means there is no clearance. Or they can actually mention that there is no clearance or ignore the clearance. You will know that there is no clearance. So in this one, there is no clearance. We do not have any relationship that goes between what? VC and VS. So our PV diagram, as we saw in the previous case, it is going to be like this. All right, so this is PV to the exponent of gamma, which is equal to, since it is what? An adiabatic, where gamma is 1,4, and at the inlet, we have 0.1, which corresponds with the V1, at this 0.2, and so forth, which is our V2, P2 here, and P1, as I stated, that the whole of this volume is going to represent our swept volume, which is our V1. So we said if there is no clearance, this V1 is going to be equal to the swept volume, which is equal to pi d squared over 4 times what? Times the stroke length. That is the idea there. Okay. But now the question is, or the question was, we are supposed to determine the power. And if you take a closer look on our formulas here, I said in order for you to have the power, you must have the effective volume, or you calculate the work done per cycle, then you use the speed at the end to calculate what? The power. But I said we can just use this formula. So let's use this formula. We just need to talk about one or two things on that formula. On the formula that we stated there, it is stating that power can be calculated straightforward from P1 VE into N minus 1 into P2 over P1 to the exponent of N minus 1 over N minus 1, like that. Provided that we are working with the effective volume, which is VE, measured in cubic meters per second, we obtain the work done per second, kilojoules per second, which is what? Which is the kilowatt. Okay, are we having P1 and P2? Yes, we have P1, P2. Are we having VA? That's the question. We do not have. The volume per second. Guys, be careful. There is no VA. But remember the relationship that we had here. VE can be calculated provided that we have what? We have VS, the swept volume. If the swept volume is there, VE can be calculated. Remember, that one is a single acting, so we use this one. And I said double acting when there's what? A 2. So we can calculate VE from VS and the speed, because we have the speed on this question here. We have what? The speed. We can calculate VS. VS is equal to V1, which is our swept volume. From where? From the diameter and the stroke length, we can calculate VS. So that means this question was going to be attempted because we have this. Remember our relationship. Let us just write it here. VE is equal to VS times N. So we need VS first. And VS is equal to pi d squared over 4. So let us just calculate our VS, which is V1. So like I said, this is our VS, which is V1, pi d squared over 4. That's pi times the diameter, 0.1524 squared over 4 times the stroke length L, which is 0.2286. So this was going to give us the swept volume, VS. So our VS was going to be 0.0041. It was going to be 416,999 like that. So it's going to be 417. VS, or the swept volume, the stroke volume, is measured in cubic meters, not per minute, not per second, not per watt. It is just cubic meters. So the reason of finding VE is to have something that is measured per unit time. So we can calculate VE from this. VS 0.00417 times the speed. Take note. If I use the speed in revolutions per minute, I specified about that. I mentioned about that. If I use the speed in revolutions per minute here, it means this VE, I'm going to obtain it in cubic meters per minute. But do I want VE in cubic meters per minute? No. In order for us to have power, our VE has to be cubic meters per second. It has to be cubic meters per second. So what does it mean? It means I can calculate this here. With this in revs per second, it gives us VE in cubic meters per second also. So that means we are going to multiply our VS, the one that we got here, times our N. Remember our N speed, VS times N, but in revs per second. So that will be 100/60. This is per minute. You calculate it in revs per second, you have your VS, your VE. So this is revs per second. The moment you do this, guys, you have effective volume. And that was going to give us 0.00695. All right, 695 like this, which is now cubic meters per second, because the speed was in what? In revs per second. So it means our VE, cubic meters per second. If we used per minute, it was going to be cubic meters per minute. With this VE, if I just use this VE, this one that you are seeing here, automatically, your answer will be in kilowatts, because that's kilojoules per second. So that's it, we are done. Let us calculate our power, guys. Sorry for that. So there we're just going to substitute. All right, let us just substitute there. That will be our power is equal to P1, the pressure. All right, remember at the inlet, what is our pressure? 101,4. So just going to substitute here. 103,4. So 103,4 times VA, which is in cubic meters per second. That's the major part there. So already we calculated this VE in cubic meters per second. So we are not going to, if we use this, we don't convert anything later on. Automatically your answer is in kilojoules per second. So you just take your VE as it is, 0.00695, all right, times N over N minus 1. So in this case, remember, it was an adiabatic, which is for theoretical, and I said we're going to use what? Gamma there. That's why you're given gamma. So that means there we're going to have gamma there, gamma minus 1. Same thing here, same thing here. Okay, so that will be our gamma 1,4. Everything over what? 1,4 minus 1 like this. Okay, that is into P2 over P1, the pressure, second pressure P2 over P1. All right, that's 620,4. 620,4 over P1. Remember P1, it was 103,4. Everything to the exponent of n, which is gamma now. So it's gamma minus 1 over 1,4 minus 1. Like this, guys. Just because of this, because it is in cubic meters per second, it means that automatically our answer here is in kilojoules per second, which is kilowatt. We are calculating power, which is work done per second. Automatically, the formula can be used, but provided that you are using the effective volume. So that was the idea. They're going to get 1,681 kilowatts. Just like that. So on a consideration that I am finding, let's say, I am determining the work done per cycle first. I was not going to use this if I was determining work done per cycle in the first place. I was just going to use what? V1. Instead of using VE, I was going to just use VS. But since they automatically wanted power, use VS to determine or to find VE, which is the one that carries per second. Then you use that now to calculate what? To calculate the power, which is VE is the one that you use for power. If you use VS, you change your answer at the end. This is what you get here. If you use VS, it will be like this, because remember I said VS is equal to V1. You have to find it like this. You calculate it like this. You find work done per cycle. Then you multiply by n, the speed in rest per second, meaning to say the answer that you get there, which is work done per cycle, you are going to multiply it by the speed, by n. The moment you multiply by n in revs per second, you're automatically finding power. But remember I said 2n when it is double acting. Okay. So that was the idea of our question there. That was the idea of the question. Let me just remove some of the things here. So let's check the other part, what we need now. So that was your power that you are done. So there are different ways of answering, but this one, it gives you an answer direct. You don't need to convert it later on. You just need to know the relationship between what? VE and V1. Now they want us to find this on question 2. Calculate, take note what they are saying here. Calculate the mass of air compressed per cycle, I said per cycle does not affect anything. It simply means calculate the mass of air in kilograms. Yes, you can write kilograms per cycle. So it is mass, just direct mass, not mass per second, not mass per hour or mass per unit time. No, we are not taking this as per unit time, but we are just taking this as the mass. Why am I mentioning this? It is because here we have got two volumes that are important. If they want you to calculate this, as mass per second per unit time, mass per unit time, you use the effective volume. Why? Why do I have to use the effective volume? Because it is the one that carries per unit time. All right? But if it is just mass per cycle like this, I just have to use V1. And V1, when there is no clearance, it is what? Our VS. Why? Because V1 or VS, it is the volume per cycle, which is just cubic meters per cycle. There's no unit to be considered there. So I have to use V1. So there they want us to determine the mass per cycle. So I must use Vs. If I use VE, I will have to use N at the end to convert. But why do you have to risk every time you have to convert? Why do you have to risk? Whilst we have a formula direct that can suit something. Let us just use the formula. So this is it. How do you calculate the mass? Remember, this is air compressors, just like gas. We know that PV can be used to calculate the mass. So from the PV is equal to MRT formula, I'm going to take P1, V1, T1 to calculate the mass. So like I said, if this mass is just in kilograms, not kilograms per second or kilogram per time, meaning to say kilogram per cycle, you use V1, which is just cubic meters, or cubic meters per cycle, which is our Vs. Remember, V1 is equal to Vs if there is no clearance. But the moment that they just say kilograms per second, the moment they just say kilograms per unit time, per kilograms per minute, kilograms per hour, there you are no longer using V1, you are now using VE, effective volume. The effective volume, because it carries per unit time. Remember I said effective volume, it's cubic meters per unit time. So to have kilograms per unit time, you must take it from a volume that is carrying also what? Per unit time. If you understand this, you are done. So let's see. So this one, it was per cycle. So that's why we have to use V1. Okay, that's why we just have to use the normal units, no per second. So to calculate mass, just divide by RT. So it follows that the mass is going to be given as P1 V1 over RT1, where P1 is the pressure at the inlet. Remember, at the inlet, our pressure was 103.4. So we've got 103.4 there. Times V1. This is the most important part. Remember, V1 is equal to what? To Vs. If the clearance is not given, V1 is equal to Vs, which is our Vs in cubic meters, 0.00417. Everything over R for air. Remember, we're given this one, it was 0.286, if I'm not mistaken. Okay, sorry for that. That was supposed to be 0.286. Then T1 is 290. So it's 0.286 times T1, which is 290. 0.286 times 290. So this one, it gives us our answer automatically in kilograms. So that was going to be 0.0051986, like that, which is 0.005. That's kilograms. So kilograms, if you write your answer as kilograms, it is the same as someone who is just writing kilogram per cycle. You are just writing the same thing. There's no difference there. So once they say per cycle, you use the effective volume, your V1, provided that there's no clearance, you are using what? V1. Okay. So we have a lot of things there to consider, guys. We have a lot of things to consider. We just need to be careful which formulas to use and how to use your formulas. It's a direct thing. So if you see your textbooks, guys, the way they want to find this, find that, but we can minimize that. So if you check the formula sheet, it tries to give us what is needed. So because we are supposed to automatically have this in a way that is direct from our formula. It's supposed to be something that is direct. Okay, so I want us to check some thing here. Another question, actually. If you check, there we have a single acting again. There it's a single cylinder, single acting. So the speed is not also affected there. It's not affected. But I want you to be careful of what is happening this time. Let us be careful. Let us move on. They are saying it takes in 1 cubic meter of air per minute. Per minute. What is it there that is taken per minute? What is it? It is the effective volume. Like I said before, that the effective volume, guys, it is the one that is taken per unit time, volume per unit time. That is effective volume there. All right. So we are given VA at the entry of 1 cubic meters per minute. All right. 1 cubic meters per minute. Okay. Remember, this is at the inlet. At P1, the pressure, 103 kilopascal. The temperature of 15. So 15 plus 273 was going to be 288. So the temperature of 288 Kelvin. And it delivers it at, so the pressure is now delivered at 700 kilopascal. The law of compression is PV to the exponent of this. So this one, we're talking it to be a polytropic, where N is given as 1,35. And the clearance is neglected. The clearance, meaning to say there is no clearance. No clearance. There is no clearance at all. The compressor speed of 300 revolutions per minute, as we are given there, 300 revolutions per minute, R for air being 0.287 kilojoules per kilogram Kelvin. So that's what we have there. And the question is, calculate the cylinder diameter. Take note. Calculate what? The cylinder diameter. We need to find D. That's the question. We need to determine the diameter, but on a condition that, assuming that a stroke 2, that is the stroke length 2 to what? The cylinder diameter, stroke 2 diameter. So we're given a ratio, the stroke length as to the diameter. It's 1,5 as to 1. So this is 1,5 as to 1. So remember a ratio. All right, we're going to talk about this. Let us just talk about this. There is no clearance here, so we shall conclude that we're going to have our diagram like this. Remember, that's what you're going to have there. So that's the point 1, point 2. And I said if the clearance is not given, our V1 is equal to what? Swept volume or the stroke volume. So the whole of this volume that we are having here is our swept volume. Okay, this is P2, this is what? P1. So the whole of this volume that you have there is your swept volume. So remember, V1 is equal to Vs. And we said that is equal to pi d squared over 4 times L, stroke volume. Okay, let's leave it like this. I was saying here, we are given a ratio that we need to consider there. The ratio states that the length, which is the stroke length, as to the diameter is 1,5 as to 1. Remember, a ratio of L as to D can be given as a fraction L over D, where the length is corresponding with 1,5, the stroke length, and the diameter is corresponding with 1. So if I do cross multiply, it follows that 1 times L, That's L is equal to D times 1,5, which is 1,5 D. So there I have now a relationship that can be written in place of L in terms of D. Or if I want, D is equal to what? L over 1,5. Sorry, if I divide by 1,5, I'm obtaining D. D is equal to L over 1,5. Or L is equal to 1,5 times D. So it depends with the question. If I want to calculate L, if I want to calculate D, depends with the question. So since we want to calculate D, it means we are supposed to use this one. L is equal to 1,5 D, so that we substitute where there is L, we remove it, and we put 1,5 D. Where there is L, the stroke length, where is it? It is on the swept volume. That is the idea there. So you need to know ratio from your mathematics, ratio. All right, 1 as to 2, 1 over 2. A as to B, A over B. So A is 1, B is 2, A is 1, B is 2. Ratio. That's the idea there. So we want to use these guys to answer the question. That is, but how? That we know that we're going to use the ratio, but how? So let's figure out how we can have our volume. Like I said, we are going to take it from the swept volume, which is our cylinder volume. But if we take a consideration, in order for you to have that cylinder volume, we need the diameter. We need also the stroke length that we do not have. So we need something that is not there. So where can we have VS? We go back here now. The relationship between what? The relationship between VE and VS. I talked about that. Let us go back here on our introduction. I said that the relationship that we have between VE and VS is this one. These two can be connected only by the speed. Take note, only by what? The speed. So that means if VE is equal to VS times N, as we want VS, because we're given VE. So VS, it's VE over N. Remember, I said the 2 there is when it is a double acting. Ours there is a single acting. So meaning to say, we are just going to take our VS as usual. That's VE over what? Over N. And remember what I said. If this is in cubic meters per second, this must be revs per second. If this is cubic meters per minute, this must be revs per minute also per unit time, which is the same, VS. So we need VS because we are given what? We are given VE, the effective volume, as we need VS. The moment we have VS, we are done. We are done with this question. Okay, we are done. So we saw that from that relationship, first we saw that VE is equal to VS times N. So to find VS, it's going to be VS is equal to VE over N. It's a single acting. Thus, the speed remains as it is. So it was supposed to be 1N, 1 times single acting. Double, 2 times N, double. So this one is. So the relationship now, you check what you're given here. How are you given? These are given as cubic meters per minute. So I said if this is in cubic meters per minute, your speed, best use it in what? Revs per minute, so that per minute and per minute cancels. You remain with your VS, which is cubic meters per revolution, per rev meaning per cycle. And I said per cycle, it means it is just cubic meters. If something is measured per cycle, it is as it is. as it is. That is per cycle, as it is. Whenever you're given per cycle, it is as it is, per cycle. So we need VS first, which is the one that we are going to need to find D, because VS, from its formula, it contains the diameter that we want here. So if we have VS, then we calculate our diameter. So let us find our VS, because we have our VA. So VS is going to be VA in cubic meters per minute. Remember, our VA cubic meters per minute, that is 1. So that is 1 cubic meters per minute over N, the speed in revs per minute. So this is per minute. Our speed in revs per minute is what? 300 revolutions per minute. So that means we are going to divide by what? By 300. That's it. Just like that. So by doing this, because this was cubic meters per minute, this is revs per minute, your answer automatically will be in cubic meters, which is cubic meters per cycle. That is just cubic meters. So VS was going to be something like 0.003333 and so on. Cubic meters. You now have VS, the swept volume, which is the one carrying the diameter. So we can calculate the diameter from there. But if I'm someone, I can just first have the relationship between the diameter and what? And that VS, because I know that VS is true, that VS is equal to pi d squared over 4 times L. But we said L is equal to what from this? L is equal to 1,5 D, because we need to find D. So you're supposed to replace this with what carries D, and it is what? 1,5 D. So we can make this the subject. All right. It's up to you on making this the subject, guys. So what I can do is to just multiply this. VS is equal to, remember, this is the same as over 1. So I'm just going to combine the numerators together. 1,5 times pi, then D squared, and D, that will be D to the exponent of 3 over 4 times 1, which is 4. Okay, just gonna manipulate here. Mathematical part to manipulate, just cross multiplies. It's gonna be 4 VS. Definitely you're gonna have 1 times this, so it's gonna be 1,5 pi D cubed. So instead, just divide by what? By 1,5 pi. So you divide by 1,5 pi, you remain with what? D to the exponent of 3. So to find D, definitely I have to introduce the cube root both sides, cube root both sides, so that this can cancel. So I have the diameter there. So the diameter in meters is going to be the cube root of 4 times the swept volume over 1,5 times pi. Because the swept volume is in cubic meters, I can calculate the volume in meters. Then I can, the diameter in meters, then I can convert to millimeters if I want. So that is going to be the cube root of 4 times the swept volume that we calculated here. That's 0,00333. Everything over what? 4 pi. So that's it. 1,5 pi. So where am I getting the 4 pi? 1,5 pi. So that's it. Our diameter in meters is going to give us something like, that will be something like 0,141, 1413, and so on. So it's going to be 141 in meters. All right, just like that. So if I want to convert, like I said, it's up to you to millimeters. You can just multiply by 1,000. So your diameter will be 141 millimeters. That's if you want. But the relationship, are we seeing the relationship of VS and VE, where it plays a role? VE is equal to VS times N. So to find VS, you divide by N. Finding VS, the stroke volume or the cylinder volume, is helping us to determine the diameter. It is helping us to determine the diameter. But also considering that ratio that we were given before. So if they want you sometimes in exam, they can ask you to calculate the length, also the diameter and the stroke length. So the stroke length, you take it from that relationship. Remember, we said L is 1,5 times D. So you multiply that by D, by 1,5 D by 1,5, you get what? You get your stroke length. So it's up to you how the question is given. But that was the idea there. All right, so that was our diameter here. So I just hope, guys, we understood this manipulation, this and that. So it's actually something that is interesting for you to have this. So it will be something like, yes, they'll give you marks there, 6 marks, 5 marks, depends, 7 marks, 8 marks. So we shall see exam questions. Actually, I've done some of the exam questions before, but here I'm just emphasizing on the explanations, because guys, we requested for these introductions. So that's it. Let us work on them. Then on number 2, they want us to calculate the power required to drive the compressor if the mechanical efficiency is 88%. We need the power given the mechanical efficiency. Okay, we never talked about the efficiencies. Let us just quickly talk about this. Whenever you have the efficiencies, they are different efficiencies that you're going to have, and that we are going to calculate in your syllabus. You need also to have or to understand this on the efficiencies that are there on the compressor. The efficiency part does not change, always output over the input, output over input. So we have got the mechanical efficiency. All right, so the mechanical efficiency is given as P out over P in times 100%. That's P out over P in times 100%. Where P in is the power to drive the motor. This is the power to drive the motor. The power to drive the power of the motor, the power to drive the compressor. This is the power of the motor, which is the power to drive the compressor. Power to drive this is the inlet to drive the compressor. To drive the compressor. All right. And this is the output power, which is the compressor power. So whenever you talk of the compressor power, that power that you're calculating using that formula, that is your compressor power, the one that you're calculating when you are using the formula P is equal to P1 VE, this, that. That one is your output power. Okay? So then we talk about the P in. Okay? Then we also talk about the other one, the efficiency that they will ask you in your syllabus that you also need to know or to understand is the volumetric efficiency. But this one, I'm gonna give you more emphasis on that if we are as we are doing question papers. But we need the volumetric efficiency. That is the effective volume over the swept volume times 100%. But we're gonna talk about that. That one, there is actually a video where I explained much on this one. So I think that'll be best that you watch that one, but I'm going to talk about that because this formula can be extended, but for the meantime, that's it. We are dealing with this. Then you also need to calculate the isothermal efficiency. So the isothermal efficiency is given as the isothermal work done. We can take it from the isothermal work done. Isothermal work done over the actual work done. All right, times that, as you know, guys, gonna multiply by 100%. Or this might be isothermal power over the actual power times 100%. So the question is, how are you going to calculate the isothermal power. So it follows that where the isothermal power is obtained from P1 VE, the ln of P2 over P1, like that. So that's your isothermal power in kilowatt. Remember, VE, I said cubic meters per second, always. And the actual power, you are going to calculate it from that formula. The actual power is always from our formula P1 VE times N into N minus 1, like this. That's P2 over P1 to the exponent of N minus 1 over N minus 1, like this, in kilowatt or so, because this is in what? Cubic meters per second. So that is what you're going to need on the efficiencies. And whenever you have a volumetric efficiency, let us talk about this issue of volumetric efficiency. Like I said, here I'm going to explain further on this one. Because remember, before we had a relationship between what? VE and VS. And we said before that VE is equal to VS times N, the swept volume times N. But if there's a volumetric efficiency, that means you're going to multiply by what? By the volumetric efficiency. That is the relationship that's going to happen. To find what? To find VE when given what? Volumetric efficiency. So we shall talk about that. So our question was not about the volumetric efficiency. No. It was to calculate power given the mechanical efficiency. So we're going to talk about this formula. That is the one that we are going to work with to calculate the power required to drive the compressor. Like I said, the power required to drive the compressor is what? It's P in. That is P motor, P in. So you want to calculate P in here. So that is the question, the power to drive the motor. That is P in, which is P motor in this case, is the one that we want. Given the mechanical efficiency of what? Of 88%, which is 0.88 as a decimal, divided by 100. But we say this must be taken from the formula that the mechanical efficiency is equal to the output over the input power, where you have the output from the normal formula and the input as the P motor, which is the one that we want, the power to drive the compressor, P motor. So this one is the one that we are supposed to calculate, but this one we do not have. So where are we going to have P out? It means we have to calculate P out first, because I said P out is the compressor power. And the compressor power is the one that we calculate from our normal formula. All right? From our normal formula of P. Remember how you calculate P. That's how you calculate your P out. P1 VE into N over N minus 1 into P2 over P1 to the exponent of N minus 1 over N minus 1. Where this is the effective volume VE in cubic meters per second. Remember I said this per second so that you obtain kilojoules per second, which represent what? Kilowatt. So thus we can calculate P out. So P out, the pressure, the inlet pressure, we have it. At the inlet, the pressure was 103. So this is 103 times VE. Remember VE, we have it. That is the one that we are given. 1 cubic meters per watt minute. This is needed per second. So I said per minute, we divide by a 61 minute, it's 60 seconds. So it will be 1 over 60. That's our volume is now in cubic meters per second. Then N, 1,35. Remember from our formula, we're given this as 1,35. So that means this will be N 1,35 over 1,35 minus 1. All right. So we're going to have this as, okay, can even times there, 1,35 everything over 1,35 over 1,35 minus 1 like this into P2 over P1. So you're going to have the power there. I mean, the pressure. Sorry for that. Just have to save a little bit. Okay. So the pressure at the output, 700. All right. Inlet, 103. So that's 700 over 103 there. Okay. There's a lot of things. Sorry, guys. A lot of things there. So we've got 700 over 103. Like this to the exponent of n minus 1. Remember, our n was 1,35. So it's now 1,35 minus 1 over 1,35. 1,35 minus 1 is 0,35. You can even subtract there, it's fine. So this is what you're supposed to have. Okay, guys, you see this thing of I'm erasing this. Now other things are remaining. It's now like part of my formula. No, the 100% was for that formula for efficiency there. All right. So this was going to give us what? The output power. Kilojoules per second, kilowatt, because we used VE in cubic meters per second. That's our power, was going to be 4.261 kilojoules per second, which is what? Which is kilowatt. This is not what our question was asking, no, but we are forced because of what? The formula there, the mechanical efficiency. In order for us to have input power, we must have the output power. So you can cross multiply, divide, that will be the input power is equal to the output power over the mechanical efficiency. So that's the input power. The power to drive the compressor is the output power that we calculated here. So if I have got this as 4,261, this is already in kilowatt. So it means my input power also is going to be in kilowatt. The mechanical efficiency of what? 0,88. Thus, we have got the input power, which is going to give us, that was going to give us something like 4,842 like this in kilowatts. So you answer according to which efficiency are you given? Are you given the mechanical efficiency? What are you given? They want you to manipulate from the efficiency that you're given to calculate whatever that you're given there. We were given the mechanical efficiency. So they want us to manipulate from there, from that mechanical efficiency to determine what is missing. That's the idea. That's the idea there. Okay, so this is not enough. No, this is not enough. Like I said, you need to understand the concept of these efficiencies and this and that. You just need to know your basics. If you know your basics, then you're done. So there's another question. Let us just consider this as our last question so that we'll check how question papers, how do they ask these questions. There we are given again that this is a reciprocating, all right, a reciprocating air compressor has an effective swept volume of per minute. So we have got the effective volume there of 5 cubic meters per minute, volume per minute, effective volume, and delivers to a receiver, a pressure to a receiver. This is the inlet, this is the receiver here. So it delivers to a receiver, this pressure, this is P2, not P1, the receiver. It is delivering from the inlet to this. So this is P2. Okay, the law of compression is PV to the exponent of 1.25. So N 1,25. The temperature of air at the end of induction stroke is, all right, the end of the induction stroke, that is your one. That is when you talk about the induction stroke, the end of it, that is the one part there, that tail part. So they are referring to the input there. Do not confuse on this one. These ones are the inlet conditions. So P1 at the inlet, all right, we are given P1, yes. Oh, they started with temperature there. Okay, T1, 32. So if we add 32 plus 273, that was going to be 305 Kelvin. P2, P1 is 103.5 kilopascal. That's our pressure there. And R for air is given as 0.287 kilojoules per kilogram Kelvin. Neglect clearance. Do not include the clearance, meaning to say there is no clearance. There is no clearance there. And we understand that if the clearance is not given, it means Vs is equal to V1, the swept volume. Remember that diagram concept, guys, all right? I talked about that. That is what it means. The clearance is not there. Okay, but is it about V1? Is it about the swept volume? We don't know. Let's see. So the question was on number 1. Take note. Calculate the mass of air compressed per minute. We had a question that asked us to calculate the mass, but it was not per second, it was not per minute, it was not per hour. It was not per unit time. What we did, it was per cycle. And I said per cycle does not affect anything. It means those units as they are. So once they want you to find this per unit, per minute like this, there is something they are hiding there. What is it? You are supposed to calculate this from the inlet, but being the effective volume, because it is the one that carries the time per unit time. Remember, guys, I talked about this on the introduction. I said these two can be related. If you still remember, these two can be related. P1, V1 is equal to MRT1. But if I use this is cubic meters, and this is kilograms, where V1 is the swept volume. But the moment that I take at the same inlet, at the same P1, with the same inlet volume being the effective volume, we use the same formula, same consideration. But what will change is that this is now effective volume, cubic meters per unit time, mass also kilograms per unit time. These two, they go hand in hand. What am I trying to say? They go hand in hand. If this is per unit time in seconds, this is kilograms per second. The moment that this is taken as cubic meters per minute, your mass will be kilograms per minute also. Per hour, per hour. That's it. That's it. Only that. If you know this, guys, you are done. So when the question is asking you to calculate the mass per cycle, it wants you to use this formula. There are no units there, like per time, per second, or per this. You take it that way. We use V1. If there is no clearance, this V1 is equal to the swept. You use the swept volume. But the moment they ask you like this question that they asked you to calculate the mass per minute, per minute, it means the volume that you're supposed to use there is the effective volume. And since we need kilograms per minute, we are supposed to take it in kilograms, cubic meters per minute also. So that is the idea there. That is the idea now. The units must correspond also. So as we need this in kilograms per minute, so we are going to use this VE in what? In cubic meters per minute. But it was, or everything was taken from what? P1, V1 is equal to MRT. But you must consider what is it that I am calculating there. Okay, so we saw that this is going to be what? This is going to be taken from P1. VE is equal to MRT1, where this is cubic meters per minute, and this must be in kilograms per minute. Okay, so this is what we saw at the end. Guys, this thing just has to save. I don't know. Okay, it's fine. So now we can calculate the mass because we can just make this M the subject. So if I divide by this RT1, I'm going to remain with P1 VE over RT1. So that's the mass is going to be P1. We're just substituting our pressure as it was before at the inlet 103.5. So this is 103.5 times VE. Since we need this in kilograms per minute, I said we are going to use VE in what? You must consider that. So am I going to change this? No, this time I'm not changing this. So I'm just going to take it as 5 cubic meters per minute. R for air, 0.287 times T1. Our temperature in Kelvin, 305. So this time I'm not going to change anything. Since this was in cubic meters per minute, this one per minute is the one that we want. Automatically, this mass is going to be what? In kilograms per minute. That's it. So that's your mass. So you're going to obtain 5.912 kilograms per minute. That was going to be your mass. So the moment, if they wanted you to calculate only the mass per cycle, you were supposed to use what? The swept volume V1 at the inlet. If there is no clearance, V1 is equal to Vs. But since they want you to find this in kilograms per minute, you must use a volume per unit time in minute also. And whatever volume per unit time, it is your VE. Your VE, effective swept volume. That is the idea there. All right. Then let's check the other one. The temperature at the end, they want you to calculate the temperature at the end of compression. So these ones are now those normal calculations of your air. Remember when we did our gases, T2, there's this formula which connects temperature, pressure. It's also in your formula sheet. So we need temperature at the end, which is T2. So remember, there's this formula about air, or when you're dealing with our gases, we are also having that formula from our formula sheet. That is T2 over T1 is equal to P2 over P1 to the exponent of n minus 1 over n, which is equal to, they can give us this in terms of volume. If you are given in terms of volume, it will be V1 over V2 to the exponent of n minus 1. So as we do not have anything about volume, so we're going to talk about what? The pressure and temperature, because we have pressure, P1, P2, and also T1. So we can calculate T2 if we just multiply this side by T1 here, this will cancel. So therefore, T2 was going to be equal to T1 into P2 over P1 to the exponent of n minus 1 over n. That's your T2. So T2 was going to be found by this. You are back to your guesses there, your laws of your guesses, all right? P2, 621 over P1, 103.5 to the exponent of n minus 1, 1,25 minus 1, that's what, 0,25. Or you can just write 1,25 minus 1 over 1,25. So this giving us our temperature at exit. which was going to give us something like 436,446 Kelvin. That's it. All right, so if we are going to need these values, guys, we are going to talk about this, but that is the idea there. That is the idea there that we are going to need. You just need to be very, very careful on your calculations. Just remember these values if you're going to need this. If you're going to need this, that's the idea there. So that is the idea there. That is the idea. Okay, sorry for that. So whenever you are given calculations on under power machines N5, try to be someone who is good in manipulation of formulas. Our mathematics N3, that maths N3, how do you manipulate that manipulation? All right, anyways, number 3, calculate the power required. That was number 3. All right, let me just take one or two things. Remember, we calculated the mass. We got our mass. It was 5.912 kilograms per minute. That was your mass there. All right, so I want you to be careful there. You want to calculate the power. So this power is going to be in kilowatt. So what happens is that for power, remember my formula, there are 2 formulas that we wrote here. We can have our power from the formula P1 VE into N over N minus 1 into P2 over P1 to the exponent of N minus 1 over N minus 1. If we have the effective volume, because we have it, it's an advantage. But remember, if also there's a mass per unit time, we can use it. Remember, I talked about the mass per unit time here on this formula. Okay, this one. We said we can have the same power from this one. All right, work done from the concept here. All right, let's hope it's gonna, okay, guys, now I'm erasing this. I'm not gonna put this one. Sorry for that. What is, okay, very sorry for that. I'm now erasing what I want, guys. Sorry for that. You see, these boards, guys, they just tend to misbehave. They just tend to misbehave sometimes. All right, it was VE, but okay, I said on this one here. If you still remember, I hope I did not erase it here. V1 is MRT1. So if I'm using kilograms, it means this was just cubic meters. But at the moment I just use kilograms per second, this must be kilograms per second, which is the one from the PE VE here, this one, P1 VE. So here we could have taken it also this to be equivalent to MRT1, but this mass must be in kilograms per second. So we can also use the mass there. I want you to go and I want you to try use the mass there. You will see that your answer will be approximately to the one that we're going to get if you use VE. It's only that because of the rounding off, here you are using exactly the value as it is. You're not rounding off. So it will be just approximately the same. So your power can be calculated either way. All right, so power P1, remember our pressure was 103,5. You still remember, guys, times VE. We already have it, but what are the units per minute? Power, kilojoules per second. So this must be cubic meters per second. So I have to divide by 60. 5 over 60. I have the volume, the effective volume, cubic meters. The moment this is per second, this will be per second. I explained that, guys. So I hope now we are together. N 1,25, so that will be 1,25 over 1,25 minus 1. That is it. Then into the pressure, P2, 621 over P1, 103,5 to the exponent of N minus 1. So that's 1,25 minus 1 over 1,25 minus 1 like this. We have the power from there. So that was going to give us the power. And that was going to give us 18,586 kilojoules per second, which represent what? Kilowatt. Kilojoules per second. Kilojoules per second kilowatt. So that was it. And like I say, this power, it represents what? It is your actual power in the calculation. Whenever I use it like this, it is your actual power in calculation. In your calculation, that is your actual power. All right, so anyways, let's see this. I hope I did not mix something about isothermal efficiency there. I'm thinking about it, guys. I hope I did not mix something there. I'm hoping so. Then the calculate the isothermal efficiency. So I say that on the isothermal efficiency, we need isothermal power or isothermal work done. Isothermal power over actual power. All right, if you still remember the formulas that we listed before, I talked about this. So this one is just a continuation. So I said the isothermal power, we can use it from the isothermal power. Isothermal efficiency is equal to the isothermal power over the actual power times 100%. You're also given this in your formula sheet. Yes, it must be. You are given this in your formula sheet at the end. That is supposed to be the last formulas of your formula sheet, the last formulas. So you check it given P iso over P actual, and they also gave you the formulas on formula number 48, formula number 49 on how to calculate isothermal power, and I also talked about those formulas. So if you check, we do not have the isothermal power, but we have the actual power, the one that we calculated. So we need the isothermal power from where? From the formula sheet, you're also given this formula, so it's not a matter of worry. The isothermal power is P1 VE, the ln of P2 over P1. That's isothermal power. So it's in kilojoules per second. Remember, VE must be what? Cubic meters per second. So if we have cubic meters per second, this will be kilojoules per second. So that's P1. Remember the input pressure, guys. It was 103.5. Yes, those inlet 103.5 VE, 5 cubic meters per minute. So we have to convert those values there. So this was 103.5. Remember, VE was 5 cubic meters per minute, but it is needed per second. Like what we did on calculating the power, we had to divide by 60. All right, so that's times the ln of P2, the output pressure. Remember, it was 621 pressure at the exit, and over 103.5, which is the in P1. So that was going to give you the isothermal power, which was going to be 15,454 to 3 decimal places. That was your isothermal power. You have the formula there. With these two, I'm done. With these two, I can be able to determine the isothermal efficiency. So we saw that we calculated everything. So the isothermal efficiency was going to be the isothermal power 15,454 everything over the actual power, which is the one that we calculated first. So the formula for the actual power, you're also given in the formula. You see it is the same formula, this one that we used for calculating our normal power as usual. So that's 18,586. So that was going to be 18,586. So that's it. We're done. So our isothermal efficiency in this case was going to give us 83,1486 like that, which is 1493 decimal places. As a percentage, this is what you're going to have. So like I said, it is the right time now to work. It is the right time as an individual to do as many questions as you can. from your question papers. We worked with some questions. Now it makes sense with the idea of this introduction that we had. You can grasp to say what have you been saying before on those question papers. So for those who have been requesting for the introductions, we are working on those introductions. It's only that we just have a lot of things to consider. As you can see, it is not only this subject, there are other subjects also. So let us just be patient and try also to do question papers where there are challenges. Let us talk about that on the comment section. But for more questions to come, let us talk about them in the comment section. Like I said, for Meson African motives, till we meet again.